Two strings are isomorphic if we can rename the letters of the first consistently to spell the second. Take egg as our example and add as the second word. Map E to A and G to D, and egg becomes add perfectly. The mapping has to be consistent both ways, though, and that's the whole challenge. The idea is to build a letter-to-letter mapping as we walk both strings side by side. At each position we have a pair, a letter from the first string and a letter from the second. If we've seen that first letter before, it must map to the same second letter as last time or the pattern breaks. And we also need the reverse to hold so that two different first letters never collide onto the same second letter. We keep two maps, one each way, and if any pair violates either map, the answer is false. First, if the lengths differ, they can't be isomorphic. Then we keep two maps, one from the first string to the second and one the other way. Walking the pairs together with zip, if the first letter already maps to a different partner or the second letter is already claimed by a different letter, we return false. Otherwise, we record both directions. Survive the whole walk, and it's true. Let's build both maps live and test a few pairs. Reject different lengths, then set up two maps, one for each direction of the renaming. For each aligned pair, reject any letter that would break a mapping we already committed to. Record the pairing both ways, and if nothing ever conflicts, the strings are isomorphic. Now, let's test it and hit run. There it is. Egg maps cleanly onto add, foo and bar clash because two letters would need the same partner, and paper matches title. The flow walks the two strings together. If lengths differ, false. For each aligned pair, if either letter would contradict a mapping we already made, return false. Otherwise, record both directions and move on. Finish the walk cleanly and return true. How fast? We look at each aligned pair once, so the time grows linearly with the length. The two maps hold one entry per distinct letter, so their size is the size of the alphabet, a small constant for ordinary text. 3 things to watch. First, checking only one direction is the classic bug. Foo and bar would sneak through, so keep both maps. Second, reject unequal lengths up front. And third, a letter's partner is fixed the first time you see it and must never change afterwards.